Hello everyone, welcome to today's class. In today's lecture we are going to start with the solution of the differential equation, and there are methods to solve a differential equation. The first method is known as separating variable, and it is exactly as the name suggests, separating variable. Okay, so idea is like suppose dy by dx is given to you. Okay, let's say 1 plus x, 1 plus y, something like that. Okay, I'm just giving you this idea. So we have to separate it, means you collect d everything related to y on one side, everything related to x on one side. So what we'll do is we'll take this here, we'll take this here. So you will get dy 1 plus y dy is equal to 1 plus x dx, and you integrate both sides. That's it. That's the key idea. Okay, let's see the questions now. You're saying find the find the solution, general solution of a differential equation. This is given. Okay, so kind of like the one that I have given you as an example. So what we'll do is we'll cross multiply. We'll try to separate. And the point is, all the questions that we will be discussing in today's lecture will be based on separating variables. So you don't have to think too much about it. Just try to see if you can take y on one side and x on other side is x on the other side. Is it possible or not, and which it will be. Okay. All right. So if we cross multiply, we get 2 minus y dy is equal to x plus 1 dx. Integrate both sides. So what is the integration of 2 minus y? That's 2y minus y square. And what is the integration of this? X square by 2 plus x. This is also y square by 2. Okay, and you put another constant c. Don't try to put constant on both the sides, because some constant will come here, some constant will come here. Then addition or subtraction of those constants will result in another constant. Okay, so if I take the LCM of the whole, or I multiply both the equations by 2 basically, so I get 4y, and I want to make sure that everything is on the one side. Okay, it's not necessary, but this is one of the possible way to express your answer, but if you want, you can write this as some equation equals to 0 also. So x square plus 2x, this y square will come also here, plus 2y. Okay, plus if you take the LCM, it will become 2c equal to 0. So we'll say x square plus y square plus 2x plus 2y plus 2c. Now this problem of this constant I'll explain. As per our solution, we are getting 2c as answer, but what will happen in the question, you will get c as an option. Now you'll think that there is a difference between them. No, actually no, because see, every time we introduce a constant, we can call it as c1. Let's say c1. So 2 multiplied by a constant is another constant. Okay, so I'll be treating this, I'll try to avoid this, but actually 2 multiplied by c is also c. What is it? Why is that? Because this is 2 into some constant which results in another constant. So if you want to avoid the confusion, what you can do is the constant that you have already instituted, if you want to change that, call that as c1, and then 2c1 is actually your new constant c. Okay, so 2 multiplied by constant, 3 upon constant, anything, any operation with constant, even log c, okay, is also a constant. Means it's not necessary I want to write c1 only. If I want, if I require, I can write log c1 also, because that's also another way to represent a constant. Okay, so while solving the questions, if sometimes I take a constant as log c, so don't get worried why I'm writing log c. That is also a way to represent a constant. Log c1 is your constant. Okay, all right. Usually students get confused about this constant point. All right, this is done. Okay, let's see the next one. I forgot to multiply this by 2. This is 4. Okay. All right. Next. Again, you have to find general solution. General solution means we are writing this arbitrary constant. This is the meaning of general solution. Means you have to express your answer in terms of C, with C actually, not in terms of C, with C, some constant. Okay. All right, dy by dx is equal to this. So again, we try to separate it. We take this 1 plus x y square in the denominator. We take dx here. Just interchange these two. So we get dy upon 1 plus y square is equal to dx upon 1 plus x square. Both side integrate. What is this? Tan inverse y. What is this? Tan inverse x plus some constant if you want C. Okay. All right. Now this was general solution. Remember, we discussed general solution in the last, the first lecture, not the last one. The first one, we barely introduced that. Okay. Let's now understand what is the actual difference between a general solution and a particular solution. The question says, yeah. So this time he is asking for particular solution. Now in particular solution, usually they will give you a condition. Condition is, what is this condition? When that y is 1 when x is 0. Sometimes it is written as y of 0 as 1. Okay, so try to read this, because when it's written like this, student get confused. It's y of 0 is 1. That means value of y is 1 when x is 0. Okay, this is the same thing. Now let's do it normally for the starting part. Right now he's asking for particular solution. You find first of all general solution, and then we'll use this condition to solve. So taking dx here, taking y square here. So you get dy upon y square is equal to minus 4x dx. Then integrate. So 1 by y square integration is minus 1 by y. Minus 4x integration is minus 2x square plus some constant c. Okay. Now what you can do is you can slightly make this better if you want. Usually the options are given like this: y is equal to something, y is equal to something, because y is your function. So if you want to make this as y, what you can do is first of all take the negative on the other side. That becomes y is equal to 2x square minus c. Sorry, this is 1 by y. So taking the negative sign on the other side, and then you write down y is equal to 1 upon 2x square minus c. Okay, it's just that it looks good like this, that's it. Okay, but you can write like this also. Again, you have to see for the options if you are matching with the ABCD options. Okay, there is no single way to represent a solution. All 3 steps are solutions effectively. Now for particular solution we have to get the value of c. Okay, this is general solution. For particular solution, what we have to do? Find c. How will we find c? Using this condition: y is 1 when x is 0. So let's put down y as 1 upon x is 0. So replace x with 0. So 0 minus c. So basically your minus c, 1 by minus c is 1. So you'll get minus c also as 1, or you'll get c as minus 1. So what is your final answer? Your final particular solution is same. Y is equal to 1 upon 2x square and c is minus 1. So plus 1. This is the exact answer. And you see how many constants are there. How many arbitrary constants are written. There is no A, there is no B, there is no C. The value of C is now written. So number of arbitrary constants in particular solution is 0. Okay. All right. Next question. Okay. It's saying find the equation of curve passing through 1 comma 1. So this is the coordinate, this is x comma y. Whose differential equation is this? So differential equation is given. You have to find the equation of curve, means you have to find a relation between y and x. Okay, and this is passing through 1 comma 1, means what is the meaning of this? That when x is equal to 1, y is also 1. Okay, so indirectly is asking for what? Particular solution. So find the general solution first. Take this x in the denominator, rest everything is okay. Dy is equal to 2x square plus 1 upon x dx, and integrate. How will we integrate? Single denominator, split it. What is integration? Nothing is there, that means 1 is there, so integration of 1 is y. This is integration of 2x plus 1 by x, so y is equal to integration, and integrate this, you will get x square plus log mod x, okay, or log x also you can write, okay, plus some c. And how will you get c now? Okay, if you want to define it properly, write down mod. Now how will you find c? This is general solution again. For particular solution we have to find c first. So 1 comma 1 is satisfied now, so put y as 1, put x also as 1, square is 1, log 1 also, plus c. Log 1 is 0, okay, standard result. 1 1 cancels, c is also 0. So your write down your final answer now. Y is x square plus log mod x, c is 0 now. So this is your final answer. Okay. Next question. Find the equation of curve passing through two. Again, same idea. X value and y values are given. Given that slope of tangent. What is slope of tangent? Now he is using AOD concept also. Slope of tangent is dy by dx at any point is given by 2x upon y square. So not writing directly that dy by dx is 2x upon y square, rather introducing the concept of AOD, that slope of the tangent, which is dy by dx effectively. Okay, so just cross multiply, take it here, so y square dy is equal to 2x dx, integrate, so y cube by 3 is equal to x square plus c. Find c. So minus 2, yeah, and 3's cube is 27 by 3, 9 is equal to x is 4 plus c. So c is coming out to be 5. So your final answer is y cube by 3 is equal to x square plus 5. Yeah. All right. Or what you can do is you can write your answer as y also. Y cube is basically 3 bracket. 1 second. 3 multiply it, so 3x square plus 15. Suppose you are given options in terms of y only, y is equal to something, so y will be generated like cube root of it. So 3x square plus 15 cube root of it, like this. Or they can literally write cube root of 3x square plus 15. This also they can write, right? So again, this could be the answer, or this could be the answer, or this could be the answer. Okay, all of them are correct. There's no proper way to say that this is correct and that one is incorrect. No. All right. Okay, now let's see a few questions simple enough on this based on these ideas. Let's check Trigo. Trigo hasn't come, You have to find the general solution. Okay. Find general solution. So let's separate. dy is, take this dx on the other side, and we have separated y and x. 1 minus cos x, 1 plus cos x dx. Integration of 1 is simple, y. Integration of this, now you have to think, you can do rationalization also, you can do 1 minus cos 1 cos property also. There are two ways to integrate. Again, it depends on your style of integration, which way you want to integrate this. Okay. Rationalization we have already discussed. Although we have discussed these kinds of questions, let's discuss this through property. 1 minus cos x is 2 sine square half of the angle. 1 plus cos x is 2 cos square half of the angle. So this is nothing but sine square by cos square. 2 cancels, so tan square x by 2 dx. We know we cannot integrate tan square, but we can integrate sec square x by 2 minus 1. Tan square is sec square x by 2 minus 1. And this integration is very simple. This is tan x by 2 divided by coefficient of x. Whatever is the coefficient of x, that will come in denominator. So 1 upon 2, so 2 minus x plus c. That's the answer. You could have done by rationalization also, your call. Depends on whether the option is given in half angle or direct in x. If he has given the answer in x, that means they have used rationalization approach. Simple questions are there. Let's look at this. So separating variable is very simple as such, because all you have to do is separate them and integrate effectively. So they are more about integration rather than solving differential equation. So for this, first of all, we'll keep this term sec square x tan y dx is equal to minus sec square x. Take this whole term on the other side, minus sec square y tan x dy. Now separate y terms and separate x term. Take this tan x here, take this tan y here. So this is sec square x upon tan x dx integration minus integration of sec square y tan y dy. Okay. Now sec is 1 by cos square sine by cos cancels. Still, I think a very direct approach right now, what I can think is just look at this sec square dx. Substitution comes in the mind or not? If this was t, numerator was dt. And same thing is happening over here also, na? Same thing. If you take this as t, this will be your dt. What is the integration of 1 by t? This is in denominator, na? So 1 by t integration is log mod t. So what is mod t basically? Log mod tan x. And this is minus log mod tan y. Plus, rather than writing c, now I told you that we can write constant as log c also, because log of some constant is also a constant. Now what is the benefit of this? If I take this term on the left, log, they will become addition, and log a plus log b is log ab. So log tan x tan y in the mod is equal to log c. Okay, log you can remove, mod also you can remove, because mod, the purpose of mod was to make it define. Okay, so you can remove the mod part also. So overall your equation becomes tan x tan y is equal to c. I think that's a good looking answer. You can keep it as it is. Okay, so this was all possible because we took constant as log c. Okay, and that's why this log we took together. So if you are getting multiple terms in after integration, you are getting multiple terms as log, take constant also in terms of log. That will help you to simplify the expression. Okay, so this is the answer for this. All right. I'll take one more question of this sort, in which you have to take you will be required to take constant as log c. Look at this question. This has a log already present in it anyway. So take this term on the other side, y log y dx is equal to x dy. So get this x here, get this term here. So dx upon x is equal to dy upon y log y. Y log y. Integrate. 1 by x integration is log x. I'm not writing mod. Okay. If we want to keep the final answer, we'll introduce the mod. This integration, you have to think how to integrate 1 by y log y. Okay. Now what I see is the complicated part is log y, so substitution could work. If I take log y as t, okay, if I take this as t, 1 by y dy will be your dt. So this is again integration of 1 by t dt. What is integration of 1 by t? Log t, or log bracket log y plus c. Okay. So rather than writing c, again you see two expressions are already in log, better take log c. Okay. And combine them. Log x is equal to log something plus log something. Multiply them, log in single c log y. and this log outside log cancels. X is equal to c log y. Okay, I'll teach you how to take log also on the other side if you want. Just c, if we want, we can take it on the other side also. Okay, so that is x by c is equal to log y. So if we want to take log on the other side, what is the inverse of log? Anti-log, and that's e actually. Okay, so it's like this: log say x is equal to 3, so that means if we take this here, so x is basically e raised to power 3. If nothing is written, base is actually e. Okay, so same thing, if we take log to the other side, it will become a raised to power x by c is equal to y. There is a good chance that the option would have been written like y is equal to e raised to power cx. Now why is that? If you call this as c1, 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 you can say that y is e raised to power cx, where c is 1 by c1. Okay, so again, 1 by constant, rather than going for this approach, my method is like 1 upon constant is also a constant, na? So I can write c in the numerator also. Okay, if you get confused, use this approach, take c1, 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 and then you can do the reciprocals. So this is a very good way to represent rather than e raised to power x by c. Okay, or you could have avoided all this, if you would have taken as a c, constant has to be written only once, I told you, but it's not a condition that it always needs to be written on the right side. If we would have written this log c on the left side, we would have got directly this as an answer. But again, don't try to memorize it that c should be written with or log c should be written with x only, not y. Don't try to emphasize so much on the constant manipulation part. Okay, c, 1 by c, c square, c cube, anything is another constant c. Okay, so any operation directly on c is same as constant c. Just remember that, and you'll be comfortable with the answers now. The only problem the students face most of the time, they have already done the answer, but when they try to match it with options or the answers given in the book, you'll say that my answer is e raised to power coming x by c, and book has given e raised to power cx. So this is the reason. Okay, all right, fine, we have learned this also. Some better question. Let's take this one. This is okay. Let's see this one. This one looks good. Again, long expression. Long expressions are good. For me, it's good. E raised to power x tan y dx is equal to, take this whole weird looking term on the other side, minus y 1 minus e raised to power x sec square y dy. What you can do is you can take this negative inside also and change this order. Okay, so that you don't have to deal with negative, so it becomes e raised to power x minus 1. Now take this in the denominator dx, take y here. This becomes e raised to power x upon e raised to power x minus 1 dx is equal to, this becomes sec square y dy upon tan y, integrate. Now this we have already just finished. Take this as t, this is your dt. 1 by t integration is log t t, that means log tan y. Okay, plus of course plus log c, because log is coming na, so we can combine rather than c. Here also you call this as, no need to take always the substitution as t, you can take it another variable, let's say it is p. Okay, what is, if this is p, what is the differentiation of e raised to power x minus 1? E raised to power x differentiation same, one differentiation is 0, so only e raised to power x dx, so that's your dp or dt, whatever you want to call it. So again same thing, 1 by p integration is log p, so log p is actually e raised to power x minus 1, so log e raised to power x minus 1 is equal to log c tan y. Okay, log a plus log b is log ab, multiply, log remove it, you get e raised to power x minus 1 is equal to c tan y. Yeah. Or you can write c, take c on the other side, e raised to power x minus 1 upon c is equal to tan y. Again I told you it's better that you write constants in the numerator, so 1 by c is another constant, let's say c1 or c, or you call this as c1 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 c1, and then do this is c e raised to power x minus 1 is tan y, where c is another constant 1 by c1. Again writing c here won't make much of a difference. If you are given this an MCQ and you have 4 options, now better match the terms which are without constants, means tan y, e raised to power x, try to match them. Constant is written on the left, on the right, not much of a difference. Okay, numerator denominator same thing. All right, we've done this. I think that's all. Okay, that's pretty much you have to understand regarding separating variable. I mean, you can keep on practicing more questions, but the idea is this much only. Okay, the name only, separating variable. Okay, I found one question that is good enough. Let's see this one last. Quick question, but let's see. The problem is dy by dx is e raised to power x plus y. Now how to deal with that? X plus y. We cannot separate this like this. We need some sort of property here. Somehow I cannot take this y directly on the left. So what we can do is I'm going to write this as dy by dx as e raised to power x into e raised to power y, because in multiplication the power gets added if the bases are same. Now I can easily separate, take this here, take it here. So dy upon e raised to power y or e raised to power minus y I can write. Okay, dy e raised to power minus y is equal to e raised to power x dx. Okay, integrate e raised to power y minus y, integration is e raised to power minus y, then coefficient of y or coefficient of x, na, like that, minus 1, and this is e raised to power x. Okay, plus some constant c. So if we combine this, we get e raised to power x, take this on the left, plus e raised to power y plus c is equal to 0. Okay, that's your answer. But they have written, see, if in this question, since they have already written the option, so it's easier to match. Focus only on e raised to power this expression, na? Sorry. Focus on e raised to power x, e raised to power y. In which option it is written? They are in addition. E raised to power x, e raised to power y, they are in addition. So this should be answer. Suppose someone wants to say no, that cannot be answer, we have to show it. Okay, fine, call this as c1. Okay, then take e raised to power x, e raised to power take this on the other side minus c1 and call this minus c1 as another constant c, where c is minus c1. Okay. Again, don't focus on constants, focus on the expressions, because rest of the expressions has negative power of e raised to power x, negative power of e raised to power y, so they are being rejected. Sorry, this was e raised to power minus y. If we take it on the other side, powers will still remain negative. Only this negative one will become positive. No? So I don't think this is the correct answer now. Then e raised to power x is only positive. E raised to power minus y is here. E raised to power x is here. This is the correct answer. My bad. Okay. So for this question, your answer is option number A. Okay. All right. That's it for this session. The class is over. See you in the next class. Good day, everyone. Bye.